All right, here we are with question 9, the inflatable raft. Okay, very common device for asking us about pressures, all right? So, we've got our raft, which is a large rubber tube inflated with air, and we're asked to describe how the motion of the air particles causes pressure inside the rubber tube. This is, in my opinion, one of these very commonly asked questions. It comes up very often, but in different guises. So if it's not about an inflated raft, it might be about a tire, it might be about a balloon. Okay, these questions come up again and again and again. All right, and the answer is always the same. The things that CIE is most often looking for is the idea that you use the fact that their molecules are colliding with the walls of, for example, in this case, the rubber tube or the rubber tire. Okay, the idea here, the thing that students kind of have trouble with is the idea that of collisions and what is colliding with what. In this case, it's not the molecules colliding with each other. That does happen. However, it is the molecules colliding with the tubing, with the container that they're in. Okay, and so therefore one mark, as you can see in the mark scheme, is for collisions of molecules with the walls or the raft. Okay, now each of those collisions makes a force, and that then leads to pressure. Okay, and again, if you're explaining stuff, all right, if you're explaining things, then you could just write down bullet points, but it's always nice to see it written down in a clear way, and this is my attempt here. Okay, bit more explaining here. Okay, we're asked, as the sun warms up, the pressure increases, and it's saying why. Well, we should be aware that if we have a higher temperature, the molecules have greater energy, and therefore they are faster. Okay, there are more collisions. Okay, also each of those collisions gives more force as well. So we've got more stronger collisions, and therefore a larger force on the walls, and therefore the pressure increases. And again, you can see that my attempt here is to make this into a bit of a story, not just giving the answer, not just giving the points. Okay, really kind of explaining my thinking. All right, so that's our explaining. Again, this is another one of those standardized questions, one of those ones that comes up again and again and again. Why does pressure increase with temperature? All right. Slightly, I'd say harder in some senses, question here on calculations. And I'll tell you why. Okay, we're told, firstly, the weight of the raft. Now, the weight is a force. Okay, we're told the weight of the raft, and the weight is a force. And we're also told the pressure, and we're asked to calculate the area. Now, this is quite an interesting one, because generally with pressure questions, we're going to be asked one of two things. We usually get asked to calculate forces or pressures. Very rarely would we be asked to calculate the area, and to be honest, there's no real reason for that. Okay, here we're going to use the equation which links area, force, and pressure. In other words, A equal to F over P. Okay, now I've drawn the triangle for this equation. Okay, and again, when you're using these triangles, you would cover up the variable you want to know. So in this case, A is equal to F over P, 1,100 divided by 500, 2.2 meters squared, okay? The way that I remember this in the multiple form is that forces push areas, okay? F equal PA, okay? Forces push areas. Okay, I'm trying to think of ways that will help you guys remember these equations, and that's why one way you might want to remember it. Another way would be simply to remember the definition of pressure, which is force over area. Okay, so we've got an area there, 2.2 meters squared, and then we're going to do another pretty big calculation. Again, it's a 3-marker. I've said in previous videos, make sure you look at those questions to see where the mark's coming from, and we'll see where this one is as well. We're asked to calculate the kinetic energy of the raft and the person. Okay, EK equal to a half mv squared. Okay, and then we'll think about what we know here. Okay, we know the weight and we know the speed, but we don't know the mass, and the mass is the extra mark. Okay, the mass is something we're going to have to calculate. We're going to have to use our W equal mg, or m equal to W over g. Okay, remembering weight is made by gravity. Dividing 1,100 by 10, that's just g, gives 110 kilograms. And you can see that there in the mark scheme. All right, there is a mark for stating that the mass is 110 grams. And that implies to me you probably get away with just writing down 110 grams. But I think in physics, show what you did, show what you know. You guys calculate it, divide it by 10, you get 110 kilograms. And then we can put that 110 into our equation and then get are 880 joules. Okay, remembering obviously that our speed has to be squared and everything's divided by 2 as well. So just be a bit careful there. Make sure that you are paying attention to those variables as you're given them. Okay, now last question. What causes tides? Well, compare my sentence to the answer. Tides are caused by the gravitational pull of the moon. CIE answer, the moon. Okay, this is where again I think they're selling themselves a little bit short. Okay, I think that answer would be, if you were to write just the moon, then I'd be wondering whether I want to give you that mark. Okay, certainly the moon is important here, but I'd like to see what it is about the moon. Okay, so again, I wouldn't gamble with that kind of answer. I would go for something a bit more. Really, we're thinking about the fact that the moon itself pulls the water and therefore causes the tide. Okay. Now you can see a little green line down here. After I did this question, I tried to think: is there any way of remembering this equation? I tried to come up with one. Okay, it's a dreadful one, but you might want to try and remember it in this way. We've got E equal to half mv squared. Okay, kinetic energy E means mass. You half to travel very v fast squared. Okay, E equal to m, in this case it'd be E equal to m half v squared. I'm not very happy with that one, but if you know a better one, if you've got a better way of remembering the kinetic energy equation, why don't you write it in the comments, okay, and share it with us. We could just remember that E equal to half mv squared is one of those difficult equations that we need to remember. All right, as usual, questions, ask them. If not, get on with the next one. Good luck.